So as I said earlier, our exam will be on Thursday. Okay. So on number 1, suppose our x is a random variable best described by a uniform probability distribution. Okay. So here our keyword is uniform probability distribution. Okay, so we have a uniform probability distribution. C is given 30, D is 70, complete from A to F. Okay, now we are asked to find, okay, let's draw this uniform probability distribution. Okay, now in order to draw this probability distribution, we need to find the function. Now, how do we find our function? What is f of x equals to? And you will be provided with the formula sheet. Okay. Okay, so we had our uniform probability distribution. Okay, 235. Okay, the function is given by 1 over d minus c. 1 over d minus c. Okay, so it will be provided to you. So d is given, which is 70, minus c is given 30, and this is 1 over 40. Okay, so let's say this point is 1 over 40. And how do we draw a function, or how do we draw a graph for a function f of x equals to 1 over 40? How do we draw that graph? F of x equals to 1 over 40. Can you write, or do you need extra? Is this okay for you all? Okay. Now, how do we draw this? What kind of graph do we get? You have a function equals to a number 1 over 40. This is a constant function, and we get a horizontal line parallel to x-axis. Okay, you draw horizontal line at 140. So we draw horizontal line at 1 over 40. Okay, our c is 30 and d is 70. Okay, so not from here, because let's say our c is here. So that's 30. So this is 30, this is 70. So you draw horizontal line starting from 30 up to 70 at 1 over 40. So you have this. Okay, so this is the graph, and you can draw vertical line at 3 and at 70, and we get this rectangle. Okay, so this is the graph here. Now let's see what we are asked here. We are asked to find the probability that x is greater than equals to 30 and less than equals to 64. Okay, now where is 64? 64, let's say 64 is somewhere here. Okay, so this is 64. Now here, what does it mean by finding this probability? So whenever we have a continuous probability distribution, this is one of the continuous probability distribution, we are asked to find the probability, and finding probability is same as finding the, if you have a continuous probability distribution, finding probability is same as finding the area under the curve, right? So since you are asked to find the probability that x takes a value in between 30 and 64, you are finding the area under the curve from 30 to 64. So in between 30 to 64, we have this part of graph. Okay, so we want to find the area under this graph. It means you are finding the area of this region. Okay, and this area will be the probability. Now we do have a formula here. The probability is given by, so you can use a formula, or we don't need even formula. This is a rectangle, and the area of rectangle is given by, how do we find the area of this rectangle? Length by width, right? So what is this distance here? What is this length here? 34. Okay, so probability is equals to 34 times the, what is the height? Now what is this height? 1 over 40. That's right. So 1 over 40. and you simplify this and you get your probability. Do you have any question? Now, so here, now the remaining up to f is same, okay? You do the same thing. You just draw the graph and you find the length and you multiply with the height, which is 140. Now let me take, for example, number D. So we are asked to find the probability that x is less than equals to 30. Now here, okay, that's something interesting. So we are asked to find the probability is less than equals to 30. Now, so our 30 is somewhere here. So our 30 is here, right? Now, do we even have a graph on the left of 30? It means that there is no any graph. And if there is no any graph, the area under the graph is 0, right? So the probability for this case is 0. Okay? Now, what about number E? We are asked to find probability that x is less than equals to 64. Now, you are looking at the graph which is less than equals to 64. So we have a graph from here to here. Okay? And we are asked to find the area under this curve. Yeah, it will be same as number A, right? So it will be same as number A. So this is 34 times 1 over 40. And yeah, the remainings are pretty similar. Can you just do the remaining like from A to F? It's a rectangle. You find the length of a rectangle. Make sure you need to have the correct region, okay? To find the area, you have to find the correct region. And once you have that correct region, you just find the length and multiply by the height, which is 1 over 40. Okay, can I skip the remaining? And if you have any question, make sure you do the remaining, okay? And if you have any question, we'll just do it tomorrow. Is that okay for you all? Okay, now let's go to the next one. Okay, so in number 2, the American mineralogists, October 2009, published a study of the evolution of uranium minerals in the Earth's crust. Researchers estimate that trace amount of uranium X, so X is the trace amount, okay? Now, is this a discrete or a continuous random variable? So they define X as the amount of uranium. Will this be discrete random variable or continuous random variable? What do you think? What kind of number amount can be? Can amount be like a 1, 2, 3, 4, or it can take any number? It can take any number. It means this X is a continuous random variable. Okay. Okay, and the reservoirs follows a uniform distribution. See, this X also follows the uniform distribution. And we are asked, okay, uniform distribution ranging between 1 and 3. Now, what are these 1 and 3? These are C and D, okay? We had a uniform distribution, and X is the amount of uranium. And the value of X ranges between 1 and 3. So, your 1 is C, 3 is D, okay? And we are asked to find the expected value and interpret. Okay, now the formula to find the expected value E of X is given as, it will be provided to you. Okay, that's the mu, which is C plus D over 2. That's the formula. So C is 1 plus D is 3 divided by 2, and we get 2. So we have expected value equals to 2. And you have to find the correct interpretation. Now let's find the correct one. Now this value gives the maximum parts per million of a uranium for the collection of all reservoirs on the earth. Number B, this value gives the mean parts per million of a uranium for the collection of all reservoirs on the earth. This value gives the mean parts of the uranium in each reservoir on the earth. This value gives the minimum parts. Okay, now what do you think? So expected value is the mean, right? So out of these two, so if you don't see mean, they are not the correct answer. So so we don't have any mean here. So this is not the correct option, and even D. Now we have the option B and C. We need to find the correct. Now, number B, this gives the mean parts per million of a uranium for the collection of all reservoirs, or it gives the mean value of each reservoir. Which one do you think is the correct interpretation? Now, is this 2 the mean value for all reservoirs or for each reservoir? It's all, okay? So expected value is, it always gives the mean when we repeat the experiment for large number of times, okay? When we find the we find the mean of every reservoir, okay? And if we find the expected value, it gives us the mean of that reservoir when we just repeat this experiment for large number of times. So our B is the correct option, okay? So our expected value is 2, and this is the correct interpretation. And the formula for the expected value, it will be provided to you, okay? Here the key is uniform distribution, and once you have the uniform distribution, you can use the formula here. Okay, next we are asked to find the probability here. So let's draw graph here. Uniform for inner to graph, we need a function. So let's find the function. And what is the formula to find the function? It is 1 over d minus c. 1 over d minus c. So we have 1. D is 3 minus c is 1. So it is 1 over 2. We get a horizontal line. If you have a uniform distribution, your graph is always horizontal line. So you draw a horizontal line at 1 over 2. Let's say this is 1 over 2. And the x is starting from 1 and 3. So let's say this is 1 and this is 3. So you are drawing a horizontal line from starting from 1 and ending at 3 at the height 1/2. So we have this horizontal line, okay? So this is the function for this distribution, and we are asked to find probability that x takes a value greater than 2 and less than equals to 2.2. Now where is 2? Let's say this is 2 here, and 2.2, let's say this is 2.2. Now we need to find the graph in between 2 and 2.2. So where is the graph? So the graph is starting, so this is the graph, okay, starting at 2 and ending at 2.2. And finding the probability is same as finding the area of this region. So let's find the area of this region. This is a rectangle, and we know how to find the area. This probability is equals to, so what is this horizontal distance? 0.2. What is the height of this rectangle? What is this height? 0.5 or 1/2. And you get your probability. Okay, we get 1. Thank you. Oh, do we get 1? Is it 2? No. That cannot be. Is it? 0.1, right?
Yeah.
Because the total area is 1, but we can't have that portion equals to 1. Yeah, thank you. So this is not 1. Okay, in the similar way, can you find number C? So you are asked to find the probability that x is less than 2.72. So if you have the graph, it's going to be very easy, okay? So make sure you draw the graph here. So we have 1/2 here. So this is 1, this is 3, and we have this graph here. So we are asked to find the probability that x is less than 2.72. So let's say this is 2.72. So we need to find the graph less than, which is less than 2.72. So from here to here. So we are finding the area of this region. Okay. And what is this area will be? What is this distance? How do we find? 2.72 minus 1, that is 1.72 time. What is the height? 1/2. You simplify, you get the probability. Yes, Sergio.
We also use the formula b minus a divided by b minus c.
Yes. So you can use b minus, but you should be correctly find your a and b, okay? So yeah, you can use the formula given. Yeah, it will be provided. But for this one, I don't think that you need to use the formula. Okay, if you have the picture, you are finding the area of a rectangle. Okay. Now, do you have any question for this number 2? No question. Okay, now let's go to number 3. Okay, suppose x is a random variable. Why we have? Okay, I think I should. We have a uniform probability distribution. C is given, D is given. Okay, now I'm gonna skip this one because you are asked to find f of x, which is 1 over d minus c, right? You can find this one. Find the mean and standard deviation. The formula is given. Okay, mean is mu is c plus d over 2. Standard deviation is d minus c divided by square root of 12. Okay, and yeah, is it okay if I skip this number 3? It's the uniform probability distribution. Is it okay? Now here, like for number C, once you have mu and sigma, you substitute here. Okay, you substitute here, you get some number, and you are finding the probability that x is between these two numbers using the same concept as we did in 1 and 2. You have a question, Gavin?
For sigma, what's the...
That's d minus c over square root of 12. That's a d minus c. Is it okay if I skip this one? Okay. And if you need help, we still have like tomorrow. Okay. Make sure you practice each of these, and if you need help, we'll do tomorrow. Okay. Now let me go to the next one. Number 4. Suppose x is normally distributed random variable. And whenever you have normally distributed random variable, what is the very first thing we do? We draw what kind of graph? Bell-shaped curve. Okay. Even without looking at the equation, you start drawing the bell-shaped curve. So we have x horizontal. We have function f of x. So we have this normally distributed random variable. Mu is given 10. So mu is at the center. So our mu is 10. Okay, this is mu. Standard deviation is 2. Mu is 10. Standard deviation is 2. So you are now once you know your standard deviation is 2, you are scaling. Okay, you are going 2 unit on the right, 2 unit on the left. So 10 plus 2, you have 12. This is going to be 14, 16, right? So this will be 8, this would be 6, this will be 4. Okay, so use the standard deviation for the scale on the horizontal axis. Now let's go and let's see what we are asked here. We are asked to find the probability that x is greater than equals to 12.5. Okay, so we are asked to find the probability that x is greater than equals to 12.5. Now where is 12.5? That's our target here. So let's find. So this is 12. So this point is 12.5. So it's a greater than equals to, right? Now are we going on the right from 12.5 or left? So our graph would be starting from 12.5 all the way to the left, right? And finding the probability is same as finding the area. Now we need to find the area of this region. How do we find the area of this region? We use the t-square. Okay. So if we have normally probability distribution, what help us to find the probability? I gave you that handout, Z table. Okay, we will be using Z table, or we can also use our empirical rule that we had earlier. Okay, now here, okay, now it gave us 12.5. That's not, Okay, so if you have normally probability distribution, we'll be using the Z table. Okay, and you'll have the G table. Now, in order to use G table, so do we have, what do we need to have? What kind of distribution do we need to have? This is a normal probability distribution. But in order to use G table, what kind of distribution do we need to have? Can we use a G table for normally normal distribution? There is a specific type of normal distribution that we use in order to use G table.
Sampling distribution?
No, it should be standard normal distribution. Okay, if you are given with a standard normal distribution, then only you can use a G table. Okay, and if you are given a normal probability distribution, we can always convert this into a standard normal distribution. Okay, now, so these are X values. Now, how do we convert these X values into G values? So what is the formula to convert X into G? So G is equals to X minus mu divided by sigma. So if you are given normal distribution, make sure to convert that into standard normal distribution. Okay, and converting into standard normal distribution means you are converting every X values into a G value. Now let's do for this 10. So what will be a G value for 10? So X is 10 minus, what is mu? Mu is also 10, right? It's given to us 10 divided by standard deviation, which is 2. 0 divided by 2, and we get 0. So G value for 10 is 0. Similarly, let's find the G value for 12. I mean, you are not required to find, but the next we need a G value for this point. And this point is 12.5. So let's find the G value for this point. So X is 12.5. 12.5 minus mu is 10 divided by 2. So this is 2.5 divided by 2. And how much do we get? 1.25. Okay.
Which is 0.3944.
Okay, now you might, okay, that's what we are. So here we are, what is our target? So we are trying to find the area of this region, right? Now, so our target is finding the area of this region. What do we know about this area on the right of 10? What is the total area on the right of 10? It is always 0.5, okay? And if we can find the area of this region and subtract from 0.5, we get the area of this region. Now, in order to find the area of this region, we use G table now here. So your G is 1.25. So this region is probability that X, not the X, I'm sorry, G, since we converted into G, probability that G is greater than 0 and less than this 1.25. And use the G table. So you look for the value of G 1.25. And what is the corresponding area? 0.3944. The yellow region is 0.3944. And our target is finding the green region. Okay, and that will be equals to 0.5 minus 0.3944. So probability that X is greater than, is there equals to, greater is going to be same, greater than equals to 12.5 is 0.5, excuse me, minus 0.3944. And what is this equals to?
10.25. Sorry, 10.56.
Okay, 0.56. and at least you must have this much work. Okay, I know you can just make sure you need to have the graph for during the exam. Okay, at least this much work. If you want to add extra work, it's okay, but at least you need to have a graph. Okay, you need to show converting x values into z. Okay, and make sure to state the correct reason. Okay, now do you have any question here? Now let's do. Now I want you to do number B. Okay, you start from the scratch. You start from drawing a new graph. Okay, do not use my graph here. So I want you to do number B. Okay, and you are starting from the scratch, and I'll do number C, and the D will be for you. And if you understand this concept, the remaining will be very easy. Okay, so find the probability that x is less than equals to 6.5, and you are starting from scratch. And if you need help, let me know. Start by drawing the bell-shaped curve. So you're gonna do this exactly same thing, okay? So, but you have to start from the scratch. Draw a bell-shaped curve. You locate mean, okay? So 0.0401, okay. 6.5 is here, okay. So you are finding this, okay. Now, convert just negative, that's good. 1.75. So they use the G table, right? Okay. But you don't have a negative 1.75.
Yes.
Okay. Now let me see. Where is your graph? I want you to say the reason, okay? You have to have the correct reason, say it. Yes, no, I need the reason. First, once you draw the graph, you locate mean. Then you find the correct reason that you are trying to find the area. That's the second step. Do you have the correct region? Yes, okay, on the left. Okay. Then you have the, okay, now you have the graph. Now it's the less than equals to 6.5, right? So if this is 6.5, then where do you find x less on the left? You're gonna set that region. Yes. Okay, make sure you set it correctly, okay? Did you set the region? So it's starting, okay. Who is the reason that you said it? Did you have the graph completed? Okay, now your x is less than equals to 6.5 now. Okay, that's the correct, yeah. After that, the graph looks good. Where's the graph? Okay, yeah, graph looks good. Okay, graph looks good. Do you have a final answer? Cooper, what is your answer? 0.?
0.0401.
Okay. Let's see, 0.0384. Okay, let's see. So what is your G value? Or 6.5? That's correct. Yes, you got the same. Now, what is the probability for, what is the area for this region? So 1.7. Probably wrong. So probably wrong.
that one?
0.75, so 17,
And 1.75.
0.459.
Yeah.
Okay, what did you use here? 0.46. Okay. Okay, like you got the final answer. Are you doing? Oh, go ahead.
599.
Yeah.
And that minus 0.5.
Yes. So, that's going to be the negative 1.75, not the positive. Mm. Yeah, that area is 0. So this this is the area for this region. Our target is finding this region, right? Yeah, just, so from here to here is 0.5. All this is 0.5, and if you subtract this region from 0.5, you get this region.
Okay. Okay, so yeah, then so 0.5 minus.
Okay. Does anyone need help here?
599. Okay, that's what you-
Can I start number C? Or you can do number C, but let me do number C.
Yeah.
Okay. Does anyone need help? Okay, let me do number C, okay? So in number C, we are asked to find the probability that X is greater than or equals to 11.32 and 15.08. Okay, now let me start from the graph here. So we have this bell-shaped curve. So our mu is 10. We want to find the probability that X is greater than or equals to 11.32. So let's say we have this 11.32 here, and we need to find 15.08. So let's say this is 15.08. So the graph in between 11.32 and 15.08. So this is 08. So the graph is from here to So this is the graph. Okay. So we are finding the area of this region. We are finding this region. So let me draw a vertical line at 10. And if you have this much during your exam, then you still get the credit, okay? So this should be the easy one here. Now we convert each value into G score. So 10, G is always 0, right? The mean always has a G score 0. Now for this one, that is 11.32 minus mu is 10 divided by 2. And this is 1.32 divided by 2. Similarly, we convert this 15.08. 15.08 minus 10 divided by 2. This is 5.08 divided by 2. Now, can you help me here? What do we have? 1.32 divided by 2 is 66. And what about 5.08 divided by 2? 2.2.
I got 2.54.
Okay, thank you. 2.54. 2.54. Okay, this is 0.66 and this is 2.54. Now, does anyone need help up to here? You have the graph, you said you have the correct region, you converted X values into Z values. Now, let's find out how can we find this area? We want this shaded region. Okay, can we find, can you help me here? How can we find this?
You have to find both Z-scores, and then
Yeah, we have that 0.66 and 2.56. Now, so is it possible for us to find the area of this region? Okay, let me call this is A1, okay? So this is A1. Let's find A1. So A1 is probability that G is greater than 0 and less than 0.66. Now, do you have any question on how I had that area A1 equals to probability that Z is greater than 0 and less than 0.66? Does anyone need help with that one? And how do we find this probability? Using a Z table. Now you look the value 0.66 on the Z table. And can you tell me what is the area we get? 0.66. You said 3, 4, 5, 4? 5, 2?
No, 2.
2, 4, 5, 4.
2, 4, 5, 4. Okay. 2, 4, 5, 4. Okay. Now, what is the next here? So, now, do we subtract this from 0.5? What do you think? Is that how we get the area? No, right? So it's not. Now, so here, so can we find this area, this total? Okay. Is it possible for us to find this area of this region? And we can use the G table, right? And let me call this total area as a A2. That's A2. And A2 is probability that G is, so from this point, greater than 0 and less than up to this point. G value is 2.56. 2.56. And we use the G table, and what is our probability? 0.4945. Okay, 45.
And you subtract that one from the other one.
So yes, you subtract A2 and A1, you get, so our goal was finding this region. So we are, okay, this color is not helping. So yes, we are trying to find this region, area of this region, and we subtract A2 and A1. Do you all agree here? So the question was finding probability that X is, let me, okay, what is the question? Greater than equals to 11.32, less than equals to 08 equals to A2 minus A1. A2 is 0.4945 minus A1 is 0.2454. And how much we get here? 0.2491. Do you have any question?
And it's the same thing for D, right?
Yes. Now I will skip number D, okay? But make sure you do number D. You have to practice. Now, does anyone have any question up to here? Okay, now let's go to the next number. What do we have here? So we are at number 5. So D is for you. So in number 5, find the following probability in the standard normal random variable. This should be easy, right? So you draw the, so it's already, it's standard normal random variable G. So we are not required to convert here. We have the G. Okay, you draw the graph, you find the correct region, use the G table, find the probability. Okay, so let me start with number 8. So we have this graph, the graph. So this is G, okay, no more X now. So G is equals to 2. So if you have a standard normal random variable, so what is the G value at the center? It is always 0. It is always 0. Okay, if you have a standard normal random distribution, the center is always 0. Now where do we find 2? On the right, right? So 2 is here. We are asked to find the probability that G is equals to 2. Now we find the graph at 2. So what is the graph at 2? We have a dot, we have a point, right? So what would be the area under this point? Is there any region under this point? No, means the probability is 0. So the probability is 0. And for the remaining, it's the same as like we did earlier. Can you do the remaining? Like for example, you are asked to find the probability that g is less than equals to 2. So we have 2 is here. So less than equals to 2 means every region on the left of 2. So you are finding this region, finding the area of this region. What do we know about our region A1? 0.5, right? Now use the G table and find A2. Your G is 2. So what will be A2? 0.46. Use the G table. So you are looking at 2 G value. 0.46. Just 0.46.
4772.
Okay. One more time. So 0.4. 772. Okay. Now what will be your answer for number B? Is it A2 minus A1 or A1 plus A2? Yes, A1 is 0.5. So you are adding these two. So this is 0.5 plus 0.4772. What about for number C? Will it gonna be same or different?
Subtract it from 0.5.
No, like for number C, you are asked to find that the probability that G is less than 2 means 2 is not included. The reasons will be the same. It means the same as number B. See, the probability when G is equals to 2 is 0. Okay, so it does not changes. So having less equals to sign or not, it does not change the probability. Now can you find the remaining up to H? Okay, it's the same as we did earlier. And make sure here that once you have the graph correct, you should have everything correct here. Okay, so we still have 3 more minutes. So why don't you find number H? Then we are done for today. Okay, and we'll start from 6 tomorrow. So find H. And once you have the final answer for H, you are free to leave.